Assalamu alaikum, everyone. Today we will be having our second lecture on the topic chi-square test. Here we will start with this term, which is called goodness of fit. So first of all, we will write some major points regarding this topic, and then we will start doing the sums. So the first point here is in a goodness of fit test, we test whether a given set of data fits a particular distribution, such as binomial, Poisson, or uniform distribution. Like a situation will be given, and you will have to test whether this given situation is suitable to describe by binomial distribution or Poisson distribution or uniform distribution. The thing is like that. This is called goodness of fit test. Next point is this test is very straightforward as we do not need to worry about which tail we are considering. The next point is, however, calculating the test statistic is very time consuming. As you know, you had to calculate the chi-square in the first lecture. You know that the test statistic, that is the chi-square calculation, is a bit time consuming and error prone as well. That's why we should always construct tables to get method marks. So don't forget that, guys. The next point is, if the expected frequency of a class is less than 5, if the value of E comes less than 5, then you must group this class with the next class or 2. Compare the test statistic with a critical value for the given significance level and degree of freedom. If you know the significance level and the degree of freedom, you can use the chi-squared table, and from there you can get the value of the critical value of the chi-square. And then by comparing the value you got from your calculation of the chi-square and the value you got from the table of chi-square, if you compare these two, you can come to a conclusion whether the hypothesis test result is significant or not. That means whether we will accept the null hypothesis or not. That means whether the desired distribution will be a suitable fit or for the test, or it is not fit for the distribution. The next point is the parameters must be calculated to carry out the test. Like which parameters should be calculated to carry out the test? Like for example, we can say that for normal distribution, we should calculate mean and estimated sample variance. These two values are needed to carry out a test involving normal distribution. If it is for Poisson distribution, then we need to calculate mean rate. If it is for binomial distribution, we need to calculate the probability of success. Then come to the degree of freedom, that is often denoted as nu, you know that. And this is number of active cells minus 1 minus number of estimated parameters. So these are the points that you should write down in your class notes and try to remember as far as possible. Hope you have written all the points here. Now, we will start with discrete distribution. Actually, in goodness of fit test, we will see discrete distributions. We will see discrete distributions, we will see geometric distribution, binomial distribution, and Poisson distribution. In continuous distribution, we will see general continuous distribution or continuous uniform distribution. So all of them will be included in our next lectures, inshallah. So in discrete distribution, if it is geometric, then expected value is to be calculated by this formula, that is n times probability of x is equal to r. If it is binomial, then we need to find p bar, that is the probability x bar by n. That is an estimated parameter here, and x bar is sum of r into O is the observed value divided by n, and here this is actually sum of xf. We know that sum of xf by N. This is the sample mean, this is the population mean, which is the estimated one. Now, N is the sample size, or we can say that number of trials. Now, capital N is the population size. As I said, this is the population size and this is the sample size. Small n is the sample size. Now, sum of F. Poisson, for Poisson, we need to find the lambda, and this lambda is sum of R into observed value divided by N, the population size. Another important point that you must write down, that be careful not to confuse N, small n, with capital N. It is very, very important. Small n number of trials in the binomial distribution, and with capital N, which is the number of times the experiment is repeated. Number of times the experiment is repeated, and small n is the number of trials in binomial distribution. Now, let us start with this topic, guys. As I said, we will do testing a geometric distribution as a model. We will do testing a binomial distribution as a model. We will do testing a Poisson distribution as a model. We will do testing a continuous uniform distribution as a model. We will do testing a general continuous distribution as a model. All of them, one by one. Now, look at this question, guys. Each of 200 identically biased dies is thrown repeatedly until an even number is obtained. So, until we get a success, that is obviously geometric distribution. The number of throws needed is recorded and the results are summarized as follows. This is the given table. Now, carry out a goodness of fit test at 5% significance level to test whether geometric distribution is a satisfactory model for the data. So, your first task of any goodness of fit test is to define the null hypothesis and alternative hypothesis. Remember, marks are allotted for this step. So, null hypothesis is geometric distribution is a suitable model, or we will write is a good fit. Alternative hypothesis, geometric distribution is not a suitable model. Now, our first task is to find the way how to get the expected values. So, for that one, you need to find the probabilities like this. Like expected value should be equal to n times the probability. And you know that what is the formula for probability of a geometric distribution. Let me tell you one thing again, that we are doing the test by taking this null hypothesis as true. Now, expected value is equal to n times the probability. And in geometric distribution, we find the probability like this: 1 minus all success, failure to the power r minus 1 into probability of success, because you have only one success at the trial at which you are getting the success, at the final trial for your success actually. Now, suppose you are getting the trial you are getting the success in the 5th trial. That means it would be 1 minus p to the power 4 into p. This is how it works actually. So, this one, in this sum, we have the size, sum of all frequencies, n. N is what? Sample size. Here the sample size is 200. So, 200 into 0.4 to the power r minus 1, that is the probability of failure, and probability of success is 0.6. So, if I multiply this two, so this is the formula that have been generated here to find the expected value for each case. For each case, we will apply this. R is the value here. R is equal to 1, 2, 3. Now, let us go to construct the table now. This is the table. I have written all the values of R and all the values of frequencies, that means the observed values, OI. So, these are the R and these are the OIs. Now, you will write down the formula, this formula in your calculator, 120 into point r to the power r minus 1. Then calc 1, calc 2, calc 3, calc 4. So, 120 into 120 into 0 0.4 to the power r minus 1. Then what is the value here? It should be 120. Then calc 2, you will get this value. So again, I'm telling you to write down this in your calculator with r as x, right? Like this, 120 into 0 0.4 to the power x minus 1. Write down this in your calculator, then calc 1, calc 2, calc 3, you will get the expected values here. So complete the table, guys. Keep the video for pause condition for a few seconds and then complete the table. I hope you have completed the table, everyone. Now, these are the values here. Calc 3, if you put calc 3, you will get this. If you put calc 4, you will get this. If you put calc 5, you will get this. Then calc 6, this. And how to get this one? This is very interesting to know. Because I don't have any greater or equal to 7, how would I put this value? Any guess? Expected values, all the expected values should be equal to 200 because these are the total number of dies. So expected values would be equal to, some of them would be equal to 200. So if I subtract these values from 200, I will get this value. So just do that, 200 minus all of this. You are getting this. This is very important, guys. 200 minus the rest. You are getting this value. Now, what was our concept? In the table, if we see any expected value less than 5, then we have to combine. We have to combine. Now we have to write down the table again. So now combine the last three to ensure that all are greater or equal to 5. So I have to combine all three here. I have to combine all three. So let us do the table now. R, the values of R is 1, 2, 3, 4, and 5. Greater or equal to 5. So this is greater or equal to 5. Because I have to keep all the, I have to maintain that the value of E is greater or equal to 5. Now the observed values. So up to 4, it is absolutely like this. And then from 5, I have to add this to get the value. So 5 plus 1, that is 6 here. So I'll put 6 here. Now expected values, number 4, up to number 4, same as here. And then for add all these 3 to get the value of the last row. So now these are the values. If I add them, it would be more than 5. Okay. Now, we know how to calculate this, the chi-square. Just use your calculator and you have to be a bit faster in your calculation, and at the same time, you have to be accurate, precise in your calculation, because these is a very important calculation. Like the first one, how would you calculate that? 126 minus 120 whole square by 120. 126 minus 120 divided by 120 whole square of the numerator. So just keep the video for pause condition for a few seconds and then complete the table, guys. I hope you have completed the table, everyone. So let us check the values with mine. 0.3, 0.5208, 0.4083, 2.8519, 0.15125. Now, some students ask, sir, how many significant figures should we use while writing down these values? So general instruction is all values should be written to 3 decimal place. However, more accurate values should be used in calculations. So 3 decimal place is okay, but if you take more, that is more okay. That's it. So now if I add all of them, I will get the value of the chi-square. So it is equal to this. This is the value of the chi-square. So here, what is the value of nu? How many active cells are here? 1, 2, 3, 4, 5. So 5 minus 1. And I don't have any estimated value in this case. I don't have any estimated value in this calculation. I didn't estimate anything. So this is the value of nu, that is 4. Now I will go to the table, and from chi-square table, if I go to the table, I have to find new 4, and significance level was 5%. So 100 minus 5%, that is 0.95. Now I will go to the chi-square table for new 4 and significance level 0.95. I will try to get the value of the chi-square. So let us go to the table, guys. So new 4 and probability 0.95. So this is the value of the chi-square from the table, or we can say that this is the critical value. Now we will write down the value here. Now compare this to, this is the value you got from calculation, and this is the value you got from the table. Now what is our concept? If the chi-square calculated is less than the chi-square critical value of the table, then the test is not significant. Null hypothesis is accepted. So here it is less than, so accept null hypothesis. That means evidence. What happens if we accept the null hypothesis? That means geometric distribution is a suitable model. Now we will write down like this, that evidence to suggest that geometric distribution is a suitable model or geometric distribution is a good fit. Just a minute, everyone. I think I have done some mistake in the notations here. This is not the value of chi-square. Chi-square would be the value if we add all of them. This is the value. If we add all of them, we get the chi-square. Actually, chi-square is equal to sum of these values. So it is better if you write like this. So this is all about today's lecture, guys. Hope you have understood. Thank you very much. Assalamu alaikum.